Okay, so there's a person standing in position A, and he moves to the right or east. If I do this little diagram here, then we're going to use north, east, south, and west for our directions. So he's moving east 120 meters, and then he turns around and he moves 50 meters back towards position C. So maybe, Loving, you can tell me what is the distance he completed?
I'm still writing it down here.
Okay, no problem. Write that example down, and then you try and do number 1 and 2, and then we compare answers.
Okay, so so I'm done.
Okay, so what do you reckon? What's the distance you completed?
170 meters.
170 meters. Okay, so distance is a scalar. So I only have a value and a unit. Now, distance is always in meter, and it's normally big D for distance.
Okay.
Now, displacement is delta X. It's also in meters. And displacement is what? Do you perhaps know what the displacement is?
Yeah, I did 70 meters east.
Yeah, very good. 70 meters east. So in an exam, this will just be 1 mark. Well, the displacement question will be 2 marks, one for the answer with its right unit and one for the direction. This is because displacement is a vector and this is just a scalar. Okay, but that's really easy, isn't it?
Yeah.
So we're going to try another example. We're going to move again. I'm just going to try and get this straight. We're going to move from position A to position B at, let's say that's 40 meters. And then we're going to go down south to position C, which is another 40 meters. Okay, so that's a right angle there. Makes it easy. So the first question is, what is the distance we completed? Going to keep it simple and then make it more difficult too. And what is the displacement? So maybe you can just do that diagram and then answer the 2 questions.
Yeah. Yeah. Done, sir.
Okay, distance is 80 meters. Is that correct?
Yes, sir.
And displacement? Slightly more difficult.
Sorry. Someone says me a question.
No, take your time. Remember that displacement is the direct line. Yeah.
Southwest, sorry, southwest. I was trying to draw
southwest.
like the thing.
Because this is going to be exactly southwest. Your displacement is going to be in that direction, which south there and west there, north and east. Okay, do you know the actual value? I'm going to use Pythagoras to say that displacement is the root of 40 square plus 40 square, isn't it?
Yeah.
And then
So
we can't use root answers. So it's 40 square plus 40 square. That gives me 56,57 meters. And you can just say southwest. No.
Okay. Thank you.
You could have done this. I'm just showing you something. It's not in the grade 10 syllabus, but it's from next year. We're just simply going to use that angle, which is 180 plus 45. So you could have had 225 degrees. That's the same as exactly southwest. But this is what we do in grade 11. So you can, in grade 10, just use southwest.
Okay.
Happy?
Yes, I understand.
Can we do another example?
No, sir. I understand it.
Can we continue?
Yes, sir.
Okay, now there's a circular like track. And we're going to start here at A. Then O is in the middle. And B is there. So we have there, a distance there, and a distance there. So I'm going to give you the radius as 20 meters. So that's like a circular track. And we are going to run on the track from A to B. So first thing, I want to know, number one, what is the distance? And number two, what is our displacement? Okay, there you have to write it down now and do some calculations. So that's going to take a bit of time. Just remember, this is like a 90-degree angle.
Okay, sir. Thank you. Mm.
You're managing.
Yes, sir.
Do you know the circumference of a circle?
Yeah, 20.
Oh,
It's just the
the
20.
circumference is 2
Oh, the
pi
radius.
radius. That's the equation for the circumference of a circle.
Yes, sir. Sorry. Thought you asked radius. So I was like, oh,
Oh,
okay.
yeah,
20.
radius is 20. Okay, awesome.
Okay, so I'm done. I answered like in math terms, trigonometry.
Well, from A to B, the distance is just a quarter of the circumference of a circle. Is that correct?
Yes, sir. Yes,
So that's a quarter of 2 times pi times 20. So what's that?
Oh no, sir. Wait.
Yeah.
So I wrote like pi. I crossed the quarter and I wrote it in half, like pi over 2 times 20 equals 10 pi
Yeah.
equals 3. Is that fine? 31.
So 2 pi divided by 4 is half pi or pi over 2. So that's 10 pi, isn't it?
Mm.
What answer did you get?
Yes. 31.4.
Yeah.
Rounded.
It's actually 31.42.
Yeah, but I rounded it like off.
Yeah, but if I round it off, I get 31,42 meters. It's 31,4159. That 5 makes the 1 a 2.
Okay.
Now, the displacement is a direct line from our starting position to our end position.
I wrote the answer quite long. AB.
Yeah.
squared AB to the power of 2 plus DB to the power of 2 equals 20 to the power of 2 plus 20 to the power of 2
And
squared.
then you
All of
took
it,
the
sorry.
root of that.
Yeah. And equals, rooted 800 and then equals 20 squared to, yeah, meters. And with that, the answer would be 28.3 rounded.
I get 22,28 meters.
So I rounded like to the first decimal
No, you
usually.
can't round off at the beginning. You have to round off at the end. So you had this. AB is OA square plus OB square. And then you had 20 square plus 20 square.
Mhm.
And that's 800.
Yes, sir.
Sorry, AB square. Therefore, AB square is 800. Therefore, AB is the root of 800, which is 28,28 meters.
Yes, sir.
Just redo that.
Oh no, so I did get the number. I just like rounded it like.
No, you can't. You have to use 2 decimals.
Okay. Okay. All
But
the
now
time
you
or
have to get direction. Isn't that just southeast? Hmm?
oh. Yes. Yes, there's not wait.
Very good.
Yes. Northeast, sorry, not south. I was confused.
No, no.
Northeast.
North, east, south, west. And we going in this direction there.
Northeast. Southeast.
Yeah, we're going
B
from
to
A to B, eh?
Oh yeah, oh yeah.
Okay, just finish that.
Okay, done. I wrote it corrected. Thank you, sir.
Okay. So now we're gonna repeat all of this. And we're gonna do the difference, or not repeat all of it exactly the same. But now we're gonna look at speed and velocity. Now,
Okay, sir.
average speed is sometimes they have a little line over the V. That just means average. That line there. That's your distance divided by your time. Your normal speed formula. And okay, so the unit is meters times seconds to the power of -1. And your distance is always in meters. So let's just use that. Your distance is always in meters.
Okay.
And your time is always in seconds. So it's basically meters divided by seconds, or meters times seconds to the power of -1. Now, this is a scalar. So no direction. Well, velocity is a vector, and we have to give direction there. The equation looks like this. Average velocity is your displacement over your time. And the units are the same. It's also meters times seconds to the power of -1. And this is also in meters. And this is also time in seconds. Okay, so now we go back to that example, the first one. Just modify it. So now if we start at A and we go to B and then turn around, let's say this is 150 meters and we turn around 60 meters. There's two questions. The first one, what is our average speed? And the second question will be, what is our average velocity? Okay, now you have to write all those notes down and see what you can do. Remember, it's distance divided by time. Oh, I have to give you the time. The whole movement from, okay, let's just do B and C there. So from A to C, it takes 2 minutes.
Okay.
No rush.
It's Sometime.
Very good. Okay.
Yeah.
Very important. You have to write down the equation, otherwise you're going to get marks. Speed is distance over time, delta t, or change in time.
The
The average
triangulation.
speed is it like a 210. And then 2
Mm.
minutes becomes 60 seconds times 2 now.
So, so I usually write the triangle. Is that fine? Like that triangle, you write
In front of the
triangle.
D.
Like no, the triangle where it's like
Oh, you don't use this triangle there.
not that. I mean, hold on, let me.
I don't understand. Send me a
I'm
quick
getting,
screenshot or photo of what you're doing.
I'm getting it. Use my phone.
Okay, I got it, man. Oh, yeah. You can do that. And you make your own triangle for the velocity one as well.
Oh,
Yeah. Fair enough.
mhm.
If that helps you, it does. It's fine. Lots of students use that.
Okay. No, I'm saying, does it count for like saying speed equals, or should we have to write like speed equals distance over time separately?
Yeah.
Okay.
I get 1,75 meters times seconds to the power of -1. That's my speed.
Yeah. Same. Yes, sir.
Okay, then do the
And so
velocity one. And then
I got 0,750.
you're doing really well, Loving.
Thank you.
Okay, so my displacement is 90 meters to the right or east. And the time is also 2 times 60. So that's 0.8 something or something like that. No, 0.75 meters per second. And that's going to be east.
Yes, sir.
Very good. Very good. Okay, now we can do example with a track. Now I'm going to try and do a track. Okay. So there's your straights. And then you have like, I don't know. Okay, I have an advantage because I can erase stuff with my pen. Okay, there is a track, a normal athletic track. Do you do athletics?
No, sir.
B, C. Okay, so the let's make D there. So the distance between A and B is a 100 meters. That's your 100-meter sprint. And then the distance from B to C is, I don't know, it's 80 meters. I don't know if that's right. It might be just wrong. So that means your radius is 40. Is that correct?
Yes, sir.
Okay. So now we're going to run all the way from A to B and then to C. Slightly more difficult. Okay. So we're running from A to B and then to C. And let's say that takes, the time it takes is 40 seconds. Okay. First question. What is our average speed? This is more difficult. And then 2, what is the average velocity? Okay, take your time because you're doing really well. And after this, we're just gonna we're not gonna do acceleration today. You haven't done acceleration, have you?
We did. I believe we did.
Okay, we're not going to do acceleration today. We're going to do acceleration with the equations of movement. Because they're only going to teach you one equation now. There's a lot of other equations we can use. I'm going to teach you all of them at once.
Oh, okay, sir.
So we're going to do forces after this, and then we finish for the day. Just give me 2 minutes.
Okay.
I'm back. If you need help, you can ask me. Otherwise, take your time. It's a difficult drawing.
Almost done a
No
bit.
problem. Remember, the radius is like 40 meters.
Yes, sir.
Are you writing a test series this term or just tests in between your classes?
Test series around the end of the term. Yeah.
When is it starting? Do you know?
Not sure. We didn't get
Okay,
the
but
times yet.
you'll let me know before the time.
Okay. Yes, sir. Okay, so I think I'm done.
All right, great. What is the average speed? The average speed is the distance divided by the time. That's a D on top there. I know the D looks kind of suspect. It's a D. Okay, so now we have to get the distance of that green line, knowing that this pink part here is half a circle. So that's half the circumference of a circle. Okay.
Yeah, like that.
Okay, so that's half of 2 times pi times 40. And that's just 40 pi. If you put that in your calculator, you'll get 125.66. So that's B to C. So the total distance is the 100 from A to B plus the 125.66. And we're going to divide that with a time of 40 seconds. That gives me 5,64. 5,64 meters per second. And no direction because it's speed. And then velocity is a direct line from my starting position to my end position. And I'm simply gonna use Pythagoras. Is that correct?
Yes, sir. I did.
This is 80, this is 100. So AC square is 100 square plus 80 square. So AC is the root of 100 square plus 80 square.
Okay.
And that's going to be 128,06. 128,06 meters. Okay, but velocity is delta x over delta t, or average velocity if you want to, and that will give me 128,06 divided by 40. And that gives me 3,2. 3,20 meters per second. At the moment, you only have to say, okay, fine, it's in southwesterly direction.
Yes, sir.
You're supposed to work out the degrees,
yeah.
but they're not gonna do that now. Ask you to do that in grade 10. Because you can actually use tan to work out that degree of the angle there. Tan of alpha is 80 over 100. You can, but this is grade 11 stuff. Okay. Happy?
Yes, sir. I got it right.
Okay, now just forces and then we're done. Force is really easy. So let's assume that I've got a surface there with a block on it. The frictional force is 10 newtons, and we are pulling it to the right with a 30 Newton force. What is the net force? Or you can use the word resultant force, same thing. The one we just do F net, and the other one we just use FR for resultant. You can choose. Have you done this?
Yeah, we did. A long time ago.
Who?
We didn't we? Seems recent for me. I feel like
You've done it. I haven't done it with you.
oh, okay. Then I think I did in
Okay,
my
so
book.
which one do you use, net or result?
I use net, so
So the net force is the applied force plus minus the frictional force. I'm choosing any force in direction towards the right as positive, and any force in direction to the left, I use it negative. That's the correct way of writing it. So now I have 30 minus 10, and that's 20 newtons east. Is that correct? Or
yes,
right? Happy?
yes, sir.
Okay, so another one. There's another block there. Okay, now I'm going to try and catch you out. There's a force to the right of 30 newtons. There's a force to the left of 50 newtons. And there's a frictional force of 8 newtons. I want to know, what is the net force? Okay, you're going to do that on your own. Write down the diagram, see what you can do. Got it?
Yes, I got 22.
No. Do you agree that the block is going to move in this direction?
Yes, to the left.
Okay, so let's use this direction as positive. The frictional force is always against the direction of movement. And this is also towards that side. So I'm going to say F net is 50 plus a -8 plus a -30. And that gives me 12 newtons, isn't it?
Yes, sir.
12 newtons west.
Mm.
Okay, just take note of it. The frictional force is always against the direction of movement.
Okay. Yes, sir.
Okay, good. Last one, which is something out of your syllabus. So yeah, I'm not going to worry too much if you don't get this right. Okay, so there's a block. It doesn't matter. It should touch, actually. I'm trying to get this straight. It's harder than I thought. Okay, there we go. So the frictional force is 20 newtons. And I'm pulling it in this direction with 60 newtons. Okay, but there's an angle, let's say, of 30 degrees. Good. Now we have a problem. Because I can't use the 60 minus 20 because the 60 and the 20 aren't, the 60 isn't parallel to the surface. So I have to do the following. Look at this. There's the block. And there's the 60 newtons. So I need to get this component here. It's called Fx, or the force X component. X simply because it's on the X axis.
So can we apply trigonometry in this?
Yes, very good.
Mm.
So there's the triangle. What do you want to do for a living, Loving?
So I'm entering law, but physics is beneficial for universities.
Yes. So I'm going to do the following. Look at this. Cos 30 is adjacent over hypotenuse. So the X component is 60 cos 30. And that I'm going to figure out. 60 times cos 30. And that gives me 51,96. 51,96 newtons.
Oh.
Good. Okay, so now I can say, look, now I'm back with this drawing. I am back on the surface. We have 51,96, and friction, we have 20 newtons. So F net is F plus minus friction, and that gives me 51,96 minus 20, and that is 31,96 Newton to the right or east. Whoa. I just want to reshare this screen. Somehow the screen stopped sharing. Can you see it again?
Yes, sir.
Okay, great. That's it. We are finished.
Oh.
Yeah, that's